Okay, we're going to practice graphing systems of linear equations in standard form by rewriting them in slope-intercept form. And we're going to use our slope as negative a over b equals our slope, and c over b equals our y-intercept. It's a convenient way to rewrite equations because it leaves less room for errors when you're doing this. And just recall that our standard form of the equation is ax. A is your coefficient in front of x, b is your coefficient in front of y, and c is your constant. So we're just going to rewrite these real quick and then graph them on the next pages. So I'm going to do negative a over b. So for my number 1, I have negative 2 over 5 as my slope. And for my second equation, I have negative 4 over 10, which equals negative 2 over 5. So basically, these have the same slope. Now, for my y-intercept, I'm going to get 6 over 5. We don't have to change our sign here. And then 12 over 10, which equals 6 over 5. Now, I'm going to graph these, but what you can see is they both have the same slope and the same y-intercept. That means they're going to be basically the same lines. I should have wrote this in green. So this is basically 6/5 here after you reduce it. All right. So this is going to be infinite solutions. We'll look at that later. So let's just write all these down. Okay, so this one's going to be 3 over 2 for number 1. And for number 2, it's also going to be 3 over 2. So we have the same slope for this. What about the y-intercept? We're going to have negative 10 over 2, which is negative 5. And for the second one, we have 2 over negative 2, which equals negative 1. So these have the same slope, but different y-intercepts. That means the lines are going to be parallel. And again, we will look at those. Okay, the last set we have, system, is negative 2 over negative 1, which is going to be, I'll just write it out, negative 2 over negative 1. Basically, you're just doing the opposite of this. So it's basically going to be positive 2. And then for number 2, our slope's going to be negative 1 over 1, which is just negative 1. So they have different slopes. And our y-intercept is going to be, for the first one, 5, because that's negative 5 over negative 1. And the other one's going to be 2, because that's 2 over 1. All right. So the first thing we're going to graph is the first one. So we're going to graph this one right here. We notice they have the same slope and the same y-intercept. So let me try to remember this. Negative 2/5 and 6/5. So I'm going to write y equals negative 2/5 x plus 6/5. All right. And the second one's the same thing. Y equals negative 2/5 x plus 6/5. So you can see it's the same line. And let me try to graph this down in here. Negative 2/5. Wait, the y-intercept is going to be a little bigger than 1. So we'll put it right here. These are hard to graph. And we're going to go down 2 and over 5. And I'm going to go up to here and over 5. So basically, and it's hard to graph again on this, but there it is. And then if I graph, that's the first one. If I graph the second one, it's going to lay right on top of each other. So basically, we call this consistent, dependent, and dependent. I'm going to do my and like that. And dependent. And it's infinite solutions because they coincide with one another. All right. Now let me look at back here. My next one had the same slope, which is 3/2, but different y-intercepts. So negative 5, negative 1. So let me try to remember that. So we have y equals 3/2 x for both, and I don't remember. I think it's -5 and -1. Yeah. So we have -5, and this one really should be in green, -1. So I'm going to graph these. So I'll graph the first one. We're going to go down to -5. 1, 2, 3, 4, 5. The slope is 3/2, so I go 1, 2, 3 over 2. 1, 2, 3 over 2. I can also go down 3, 1, 2, 3 over 2. So here's that one. All right. The next one, my y-intercept is -1, but with the same slope. So we're going to go up 3, 1, 2, 3 over 2. Down 3, 1, 2, 3 over 2. And I'm going to graph this as best as possible. We have two parallel lines. That means we have the same slope, but different y-intercepts. That means we have an inconsistent system. And there's no solutions because they never, the lines never touch or intersect or coincide. Okay, and the last one we have is 2, -1, 5, and 2. 2, -1, 5, and 2. Let me see if I remember that. So we have y equals 2x, y equals -x, and then I can't remember, 5 and 2. All right. So plus 5 and plus 2. All right. So basically, I'll write this one in blue. And I'm going to graph these. And we're going to go up 5, 1, 2, 3, 4, 5. I'm going to graph my y-intercept. Then I'm going to go up 2 over 1 and down 2 over 1. And keep graphing down 2 over 1 and kind of get a general line here. The other one is my y-intercept is, I'll do this one in green, is 2, and my slope is -1. So we're going to go down 1 to the right, up 1 over here, and then kind of graph that. And we have one solution. It's right there, and that is -1 is your x, and y is your 3. So basically, this is called consistent. The lines are independent of one another. They're different lines. And we have one solution. All right, and that's the solution. The next video I'm going to do is just graphing. So there'll be some equation will be y-intercept form and some will be in standard form. And we're going to just mix it all up. And that's all, and have a nice day.